Hello and welcome to my 9.3 concept elaboration task for SIT102 Introduction to Programming. In this task, to meet the credit rating, I would be able to demonstrate that I have developed a good understanding of the concepts associated with this unit. So therefore, I'll be explaining the 4 main concepts and artifacts that I have applied in my 7.2c game Part 2 work. So the core concepts and artifacts that I'll be explaining today will be the dynamic arrays, the concept of repetition, the concept of selection, and multiple value attributes under one entity, also known as struts. So in my 7.2c game project part 2, we created a new strut called game data. This allows us to hold a new vector named power up data. This vector is used to store the power up data with its corresponding x and y axis, and it's also its power up type. This is very useful as it allows other procedures and functions to access this data and then use it for the selected case. So let's just say add power up data. This will be the procedure that will add in the new power up to our array. Apply power up will apply such power up when the player hits such power up. And then we also have remove power up. So this will remove the selected power up from the vector. I'll explain this more in depth later when I'll have my code up. Next, we have the concept of repetition, loops. So the entire program is basically in a huge loop. From basically when the program starts, it's in a while loop, while not quit requested. So we'll continuously update the game, and then we also draw the game. So a good example of a loop in our program will be check collisions, because this is probably one of the most important ones. So check collisions allows us to check if the player has collided with an object. So in this case, we made it to check that it has it been collided with a power up. And this is checked over and over again. So if the player never touches a power up, the power up will never be applied. So I believe this will be a pretty good example of a loop. So if the player is not hitting a power up, then don't do anything about it. If the player hits something, do something about it. Another important loop will be the draw game one. So the draw game is, since it's in the main loop, it will continuously draw the game, allowing us to see the important part of the game. Once again, I'll explain this further once we go through these slides. Now, the concept of selection. So if statements, basically true or false. So in this program, in the game project, there is so many if statements. So basically everything, nearly all the user actions and conditional testing is done with an if statement. So one of the most important ones, so the one that allows us to control the sprite, will be the if statements that allow us to move the player. So you can see that if key down is left, we'll move the player. Otherwise, it's always false because the key is not down. And once again, this goes back again with the loop statement. So it will continuously loop. Another interesting if statement is checking if the sprite or the player is still within the boundaries of the playing field, or even this one. This is to check whether it is moving left or moving right. So this allows the camera to follow the sprite. And the last one that we'll be explaining is the struts. So struts, most importantly, it's multiple value under one entities. So in game data, we hold another strut. So the strut player data, which is displayed over here. We also have the vector. So the vector, as explained earlier, it is to store the power up data. So the game data and player data is very important to this program, as without it, the program basically won't run. It won't know what sprite it's using. It won't know what score. It won't know what ship kind it's using. The health, the fuel. So yeah, it's struts in this program are basically the brains. Like, it stores all the memory of what's happening. It remembers. Yeah, and everywhere in the program it's accessible. So now I'll be showing you the code. Alrighty, so now with the code, we'll start off with lost in space. So we'll start off with the start point. So as explained earlier, the program starts at int main. It will first load the window and obviously create, load all the processes. So you can see that we create a new strut and also reset the game data. So we'll follow this, and you can see the new game data. Like, we will start filling up our struts so that it has all this data, so the game can be played, like all the default variables. So we'll load all these default variables and obviously return the result. So once again, we'll go back to our lost in space.cpp, and then the result is returned. So now with that loaded, we can now go to our loop and start looping the game. So our first one is update game. Obviously the game will go through a series of loop. It will continuously loop. So this is once again like repetition. We are processing the event and handling the user input, updating the player, and also checking for collisions. Fairly simple. And we also have draw game. So drawing the game is pretty self-explanatory. It's drawing the game, making sure all the entities are drawn. So this is a really good demonstration of a loop. So while the game data is higher than 0, we'll draw all the power ups. So yeah, this is like a really good demonstration of a loop. Like repetition, like we'll basically check if there is like any power ups loaded. So if there's 10 power ups loaded, we'll basically let this procedure run 10 times based on the data size of the vector. Now we'll explain. So we've done vectors. Now we'll explain our struts. So struts are pretty straightforward. So our player data strut. So as explained earlier, the strut is basically the brains of the program. As the brains of the program, it stores all types of important information for the program to run, which includes the sprite data, score and stuff. This is accessible throughout the program as it is passed on through, passed on by reference. Like, every single procedure and function will have some sort of reference to game data. So they have like access to this, the strut. They can actively edit or delete data off it as required and set out by the game. Another good example of selection statement will be the switch. So a switch statement is basically a big if statement, but that looks a bit nicer, and also can be used as an enum. Like enum are just a bunch of set numbers, and you know set it like this. So in this case, the switch statement used here is basically, switch type, like which type of power up to apply. And we get this by the numbers. So 0 is fill, 1 is coin, 2 is bullet. In this case, we're basically checking if it is any of these. If it's not, obviously something's wrong, we'll do nothing. Yeah, so in the end, I believe, I've explained sufficiently about the core concepts and artifacts of my 7.2 game project. And hopefully the showcase of the implementation is sufficient. Thank you.